We are the Thomas Jefferson University Attached Housing Team for the Solar Decathlon. In this project, we wanted to achieve more than just net zero energy. We focused on net zero energy, net zero water, economic affordability, as well as the ability for this to be done on a block scale and even replicated across the city of Philadelphia and the rest of the country. We also wanted to take into consideration the views of the community we are working in to help better our design. We are working alongside industry professionals from Integral Group, Wiz Janie Elsner Associates, Mosaic Development Partners, Ginkgo Vernacular, Lower North Philadelphia Community Development Corporation, Philadelphia Housing Authority, Habitat for Humanity, and Reinvestment Fund. These professionals have worked with us to make our designs tangible and have validated our ideas throughout the process. As a team, we've had many community meetings and communications with the people of Sharswood, through which we have learned so much about this community and what their struggles and needs are. Their feedback has helped us design solutions that will truly impact their community. This neighborhood and community that we have come to love is historically African American and has been abused and neglected with a long history of redlining and discrimination. Over many years, the people of Sharswood were denied home loans and financial help from banks and lenders to support new development or improvements within this neighborhood. This has led to many rundown and abandoned single-family homes. These racist redlining practices have since ended, but the financial impact remains. Sharswood's poverty rate is above 50% and its unemployment rate is 80%. Because of this, people are living paycheck to paycheck, and nearly 70% of Sharswood residents are renters, with the majority of building stock built before 1940 and limited funds for upkeep. The value of existing properties continues to go down for those who are homeowners. In our meeting with the community, we heard a resounding need for homeownership and the ability for residents to age in place in the neighborhood where they grew up. Sharswood has almost 250 vacant existing homes, which, if renovated, could become a place where existing renters can have a forever home. This allows them to stay in the area where they are born and raised in. In addition, the vacant homes, many blocks have gaps, which we call missing teeth, between two row homes where one was torn down. This exposes the party walls on either side, increasing heating and cooling costs for those residents along with more chances for water damage. We have identified these lots as opportunities where new development can support existing homeowners. PHA has designed a rehabilitation plan for Sharswood, but their plan requires entire blocks being raised and rebuilt according to their standards. Because no block is completely empty, this involves invoking eminent domain on vacant homes as well as occupied homes. Homeowners are compensated, but according to accounts from community, that compensation could be as low as a few $1,000s for an entire home. PHA is then providing affordable rentals, but not only is their waiting list so long they can't possibly rehome everyone they displaced, they're turning homeowners into renters, which only reinforces the cycle of poverty and instability. While residents of Sharswood struggle to make ends meet, new development coming in from Brewery Town to the west is causing property taxes to rise. One of the major driving forces and takeaways from a community meeting for our project was the past developers that had come into Sharswood and take advantage of the financial status of the neighborhood. The people of Sharswood are so passionate about their community and are willing to defend their community and stand up against developers and other outsiders coming in. These said developers are coming to neighborhoods and not taking any of the community into consideration, only the profit they receive. Building codes are being pushed to their limits and communities' wants and needs completely disregarded. Hearing these needs, we made a goal of our project to change how economic development works in abused neighborhoods like Sharswood. Designing a new model for low-income home ownership supports a multi-generational living and allows current residents of Sharswood to age in place. Through this process, we found that while designing net zero affordable individual homes can have an impact on one family, attached housing can have an even greater impact when we reconsider how development can occur at the block scale and even city scale. By designing a system of development in which new construction is paired with renovations and linked to an entire grid of solar and water management, we have discovered a way to fund low-income housing while encouraging a mixed-income neighborhood that retains and upgrades existing building stock, fulfills the same needs for new development, and proposes a new way to manage water and energy at a city scale.
Our extensive research and attempts to understand the neighborhood led us to a relationship with Darnetta Arce, director of the Lower North Philadelphia CDC. This is a new development corporation that is focused on providing low-income housing in this rapidly gentrifying neighborhood. Donetta came to us with a vacant existing property donated to the CDC by the Philadelphia Housing Authority that she planned to renovate using normal means. Together, we agreed that designing a net zero energy retrofit for the building would be an excellent pilot project for the CDC. Essentially operating as a mini firm alongside professional architects, engineers, and industry partners, we hope this project will set the stage for sustainable, affordable development across the neighborhood. Together, we agreed that designing a net zero energy retrofit for the building would be an excellent pilot project for the CDC. Essentially operating as a mini firm alongside professional architects, engineers, and industry partners, we hope this project will set the stage for sustainable, affordable development across the neighborhood. Working with engineers from Wist Janey Elster Associates, we spent time opening up and examining the structure both inside and out in order to find if anything could be deemed salvageable. Our analysis led us to the conclusion that the majority of the structure needed to be replaced. In response to the building's existing thin, crumbling brick party walls being unable to structurally support the pocketing of new, larger joists, we developed a scheme that allows a totally new structural system that is entirely independent of the building's shell. The floor joists are supported by 2x4s that are framed next to the party walls. This method allows us to avoid the brick while also allowing for electrical runs and added insulation. The new framing scheme rests entirely on 4 I-beams. These are supported by 8 square steel columns, each with a new footing placed 1.5 feet away from the basement party walls. Reworking the framing scheme allows us to address a drainage problem on the roof, sloping the back section of the home towards a gutter. This not only prevents roof damage, but will make it easy for the home to be connected to a rainwater collection system if the resident so chooses. The insulation along the party wall is mainly for acoustic purposes, as the homes next door are occupied and provide a sufficient thermal barrier, but gives the project a level of resiliency in that it maintains a thermal barrier in the event that a neighboring home were to be abandoned, catch on fire, or be torn down. According to our energy analysis, the walls exposed to the exterior require an R value of 30. Our research led us to insulate on the interior of the brick using Havelock wool insulation. With a modest budget of $200,000, we designed the home to be as airtight and energy efficient as possible while discovering ways to make the project affordable through material choices, as well as clean energy fund financing, which gives the project a lower interest rate for sustainable elements. Following talks with our client Darnetta and red lines from our onboard licensed architect, we developed a new scheme that includes 3 bedrooms and 2 full bathrooms on the second floor and a half bath on the first floor. A flexible space is included in the rear of the ground floor that can be used as a home office, a play area for children, or most importantly, can be converted into a 4th bedroom for a mobility-challenged family member. This design decision is in response to the community's calls for accessible design and the need for elderly family members to age in place in an environment that is dignified in the neighborhood they grew up in, and all on one level. A large half bath is adjacent to the space and leaves room for a homeowner to convert it into a full ADA accessible bathroom later. Accessibility is a huge issue in many row homes because of the traditional 3-foot stoop, but the back entrance is only 5 inches above grade due to the slope of the block. Thus, the back entrance can be used as an ADA entrance with the addition of a ramp. All of these measures seem small, but will have a huge impact on the quality of life of a person who may be confined to the upstairs of the row home or rely on another person for mobility.
So in addition to creating this social and economic resilience, the home can function entirely off the grid by producing more energy than it needs. It does this through implementing net zero energy construction strategies, such as making the interior side of the envelope airtight by a well-insulated wall and using the ERV systems to transition the air from the inside out, and to achieve the high thermal performance. In order to make sure the building would achieve similar performance value whether located on north, south, east, or west, we run a series of tests through a software called Cove2, an innovative cloud-based software that generates building performance through energy modelings. For light penetration, the building is orientated in 4 different directions, and the result show from Cove2 that even though the building is facing different directions, the light penetration will not affect the building envelope performance drastically. To achieve an efficient EUI value, the building uses an R value of 50 for the roof and R35 for the exterior envelopes. The building will also be equipped with a triple glaze low E windows to decrease the EUI performance. After running a series of simulation, we reached the lowest EUI value of 13.51. In addition to excess energy produced through solar panels, the building is expected to have an excess of around $750 worth of energy per year.
Okay, so now moving on to the urban infill model. We initially set a goal to sell the infill for $600,000 and designed the plan so that the amenities are in line with neighboring new construction projects. When we designated this price, we compared the selling price to the surrounding area to ensure that this was justifiable and not out of reach, which after analyzing similar properties, our selling price is very tangible. The infill model has 3 bedrooms, one being a large master suite taking up the entire 3rd floor, and a large light well through the entire unit in the center. This will make the project unique and stand out while also increasing its value. The infill model is designed for the scenario with the toughest design constraints on our site, fitting into the smallest lot, 14 feet wide, that could exist between existing row homes. Our infill design will be rotated on the 4 different cardinal directions. This allows for our infill unit to have the same floor plan, just enlarged to fit within the larger site in a different cardinal direction on our block. This would only have small differences, specifically within the allowances on the interior spaces. The infill model also uses an advanced framing technique that increases the R value, reduces material waste, and provides wide 4-foot windows that also allow for more light into the space. The details for the infill are similar to the renovation as we've used consistent materiality. The only difference between the two is that the reno has thinner party walls and thicker exterior walls. Another main difference is in the framing and exterior cladding. The target market for this design is someone coming into the neighborhood. This kind of luxury row home is similar to the development already occurring, but our design aims to take advantage of that existing and use the profit from newcomers to support the cost of selling the renovations at a lower rate than it costs to construct them. This not only provides more net zero housing in the neighborhood, but it also supports a mixed income community and turns renters into homeowners. After our cost estimation was finished, we've concluded that an individual infill will cost approximately $371,000. This section perspective shows all the net zero design solutions that we've incorporated. Our goal for the infill is that it produces 200% energy it needs, as well as being net zero for water. This water is then stored in tanks within the solar chimney, which adds an aesthetic and educational element through our reclaimed pipes. These pipes then circulate the potable water for the unit and also allow for the unit to be off-grid for water. A building can't be truly net zero if it's not considering water. This model uses repurposed pipes that hold the water that used within the property. We designed a system for water collection and reuse that captures heat and reduces the load on the hot water boiler. The infill model uses an innovative filtration system to capture rainwater from the roof as well as from the street, suggesting that whole blocks could manage street water and then use it on site. This exceeds the water needs of the household while eliminating runoff into the combined sewer system. This makes the home more resilient because it's not reliant on PWD and it uses less energy. The water is then drawn up from the basement and reused within the unit. We have also included other capabilities within the unit aside from water. Highlighted is the light well that also serves as a solar chimney, which helps us achieve our more ambitious energy goals with passive ventilation. In the winter, the water pipes not only serve as water storage, but also help mitigate the heat loss from the solar chimney. By having the pipes a darker color on the south, the sun will help to heat the space. This is also supplemented by window blinds on the north to help take advantage of the sunlight. During the summertime, the solar chimney also reduces energy loads, provides a passive ventilation strategy that is supplemented by an ERV/HRV. Extra cooled will be provided by the backyard bioswale, and sensors will detect optimal temperature differences to automatically open the top of the solar chimney for ventilation. Our solar chimney is supplemented with an ERV that dehumidifies the house during evenings and hot days and then serves as our HVAC system. Once again, by collecting cold from the bioswale in the backyard to combat the hot and humid summers. We have also laid out stacked plumbing for the infill model, aiming to be as efficient as possible with water usage and waste. This method pictured also cuts our construction costs by decreasing the amount of resources that are needed. Within the reno and the infill, we have kept the materials consistent to the lower costs. The materials that were used on the interior are bamboo flooring and granite countertops to give the interior a luxurious look. Here is a photo to show what the spaces will look like at the end of construction, and then how the space will also influence and impact the tenant. Our aims for this unit are to have plenty of natural light and to make the space very comfortable for all the residents.
Using the same energy modeling simulation strategies as the renovations, when evaluating the infill unit on all 4 cardinal directions of our blocks, the house will have an EUI of either 14 or 15 compared to typical coast standard constructions, which has double the EUI value of 30. So based on the energy simulation, increasing the R value for the wall and roof to an extent did not reduce the EUR value of the building drastically. An R value of 35 for the wall and 50 for the roof are enough to satisfy while saving costs. With smart integrated sensor and energy star plans being a factor into the simulation, it generates less power consumption. Triple glazed windows with a U value of 12 and solar heat gain coefficient of 0.38 were used for the simulations. The U value and solar heat gains coefficient did not also make a difference according to the simulations. With the excess energy produced by solar panels, a typical 14 by 35 property in Philadelphia can expect to generate almost $600 a year in excess energies.
Individually, these models can be propagated all over the neighborhood. Our infill model can fill in 228 vacant lots between buildings, and 245 vacant properties can be renovated to produce a net positive energy balance, as well as heavily reducing the burden on water management in the city. Row homes make up 60% of housing in Philadelphia, as well as a significant portion of building stock nationwide. Our individual designs have the potential to transform attached housing development and renovation across the city and even the country. In addition to our technical goals of being both off the grid for water and energy, we also set social, economic, and cultural goals based on our meetings with the community members. A single net zero energy row home can improve economic stability and quality of life for one family, but we wanted our project to have the potential to impact the entire community of Sharswood. We set out to do this through a block scale intervention that combines infill and renovation models for a total of 12 units. Our plan for 6 infill models and 6 renovations sits just 1 block north of Girard College. We began by filling in gaps between existing buildings, leaving large open areas for public shared space and back-of-house access. This led to the design of a shared backyard model that connects these open spaces, increasing accessibility while providing community space and resources that increase social and economic resilience, food access, air quality, and public safety. The idea for a shared backyard stems from an obvious waste of space in existing Philadelphia city planning. Lots are required to leave 25% open area, but because there isn't much space to move around, these tiny backyards are often neglected, used for storage, and fenced in. Instead, the front porch, stoop, and sidewalk have become the cultural playground in Philadelphia. In Sharswood and many North Philadelphia neighborhoods where city planning does not allot space for public parks, this means there's not much green space for residents to enjoy. To utilize this wasted space, we developed a backyard buyback program in which residents would still own their backyard, but receive a subsidy from the Philadelphia Water Department to take down their fence and offer a portion of their land for shared space. This becomes a safe, sheltered area for the residents to gather, cook together at shared grills, grow produce, and build a sense of community. This model is inspired by co-living models where shared spaces are looked after by everyone, which encourages residents to have a sense of pride in their neighborhood and to get to know their neighbors better. This shared backyard space also provides a solution for the rainwater management problem in Philadelphia. The current sewer system is combined with rainwater runoff, which means that every time there's a major storm, the sewage overflows into the Delaware River. The city pays so many fines to the Environmental Protection Agency every year for violating the Clean Water Act that it actually has a budget for that purpose. This contaminated water is the city's main source of potable water. The City of Philadelphia recognizes the flaws in the current system and has proposed some strategies for rainwater retention. Curb cuts from the street feed into rain gardens, which vary in size and are funded from the same budget that pays fines to the EPA. However, these strategies do not address the runoff from buildings and are few and far between. Our design proposes a new model for water management in which the city block can become a tool for rainwater collection, filtration, and retention, which will eventually lead to the closure of the combined sewer system and the rejuvenation of our city's rivers, saving the city of Philadelphia thousands of dollars in fines per year. Using the most advanced water modeling program in the world provided by our engineering faculty at Integral Group, we determined that roof collection alone is enough for each unit to have a positive water balance on an average year. This graph shows the water balance as the black line. Although it dips below 0 gallons in the dry months, the excess water collection in wet months nets a positive balance. In a dry year, however, the infill homes with smaller footprints will struggle in the drier months, dipping too far below the line for the wetter months to balance it out. However, when the collection systems are consolidated at the block scale, shared cisterns allow excess water from the larger roofs of the renovations to offset the large dips below the line for the infill models in dry years. Integral Group's advanced computing system takes into account wet and dry years to determine the optimal cistern size so it is never empty. Using this tool, we determined that 12 units would need a total storage capacity of 37,500 gallons. The block is phased into 3 sections of 4 homes, each with their own 12,500 gallon tank that is integrated into the landscaping. Each unit includes smaller day tanks for potable water and treated water, which are easier to maintain and hold enough water for about a week's worth of usage. Adding new amenities such as play areas and parks in each phase helps convince neighboring properties to participate in the backyard buyback program. In the final plan, it is assumed that 80% of the block will opt into the program, allowing space to connect the bioswales. Block operations are powered by panels that are entirely off the grid, with a battery located in an existing vacant property which we have identified as a potential location for a laundromat. Laundromats are community hubs in many Philadelphia neighborhoods, so we hope this will build a sense of community while also reducing our water usage in the units. The second floor is a flexible community space that can double as a satellite office for the CDC, making operations easier for the whole block. The laundromat's water supply is a separate system which diverts runoff from the street and through the backyard bioswale. This bioswale becomes a collection location as well as a first layer of filtration before the water is pumped through a series of filters and used in washers. Local flora helps retain and filter the water and doubles as a carbon sequester, which cleans the air for the whole block. This system has a positive water balance of over 30,000 gallons per year, even with 16 washers. This shows the enormous amount of water runoff that's going to waste every year and contributing to the contamination of the Delaware River. This excess water will be retained and reintroduced to the aquifer through percolation pits in the bioswale. We initially proposed this bioswale in the backyard of the infill properties as a source of cool for the solar chimney. At the block scale, this bioswale can then run through all the yards participating in the backyard buyback program. This creates a cooler outdoor environment which actually improves the performance of all the existing buildings as well. If the water department made it a priority to retain water in backyards on every block while converting existing and new homes to a rainwater capture and reuse model like the one we are proposing, the aging sewer infrastructure could eventually be retired and water quality in the river would increase over time. We recognize that all of these elements come at a price, so we began to design a business plan in which a portion of the profit from selling an infill model at market rate is able to bankroll an affordable renovation. The net profit from a paired infill and renovation is about $180,000. Although this is successful, it does not leave room for revenue growth. Adapting that core concept, we designed a growth model in which profit from installing solar panels around the neighborhood will be able to fund construction and exponentially grow the profits and the capabilities of the CDC. Beginning in 2021, the CDC will become a solar company. The cost of installing solar on an existing home is about $5,000, which is an extremely low number due to the capability of the CDC to utilize workforce development training as an inexpensive installation tactic. The CDC can then afford to sell energy to homeowners at a lower rate than the Philadelphia Electric Company, while selling excess energy back to the grid. After 2 years, these panels are paid off by their own yearly revenue, and the CDC can borrow against the expected income from the panels to fund building construction. When construction is finished, profit from the infill model will pay off these loans while netting a profit for the CDC. Investing a portion of this profit into more solar for the neighborhood will increase the CDC's assets, allowing them to borrow more money and increasing yearly revenue. This model propagates, with solar installations increasing the CDC's borrowing capabilities, and profits from construction increasing solar installations. After 5 years of this, the CDC is then capable of financing the model which we are proposing at the block scale. By owning over 62 solar arrays, the CDC has the capability to borrow against these for $1.2 million, which is the maximum loan from Reinvestment Fund's Clean Energy Fund. This supports 2 infills and 2 renovations. After operations costs, this leaves the CDC with a profit of over $200,000 to do with what they wish. Excess profit can be used to bankroll an additional renovation, provide solar to 40 more homes, used as a safety net or for debt forgiveness, or it could go into other community improvements. This business model encourages mixed-income neighborhoods of net zero housing that utilize passive strategies, reduce the burden on the electric grid, and eliminate the need for an aging combined sewer system through an advanced water model. Our business plan proves that financing this is not only feasible, but the system nets more profit each year as solar spreads across the neighborhood, giving the CDC a safety net and allowing them to adjust this model block by block. This has the potential to inspire other development corporations across the city and even the country to implement this as a new model for regenerative development in low-income communities. Thank you.